In this video I'll show you how math is done with fractions and decimals in the binary system. Just as before, this will be the side on the page for binary and this is for the decimals, so you can compare and contrast the two. The place values for fractions and decimals are really interesting in the decimal, and to do that I want to contrast it here with the decimal that you're familiar with. Yeah, that one is the red. So the place values for whole numbers were the ones, that was a ones column, a tens column, and hundreds. Those are for the whole numbers. For the decimal digits, what you do is the decimal is a 10 based, so you take the base number, and if you want to generate bigger and bigger place values, you take the last place value, multiply it with the base number, you get the next place value. You take that place value column and you multiply it with the base, you get the next one. So to go this way, to go into the decimals, it needs the same logic. You take the base number, you divide by the, you take that place value column, you divide by that, and this is where the tenths go. You take that place value, you divide it by the base, that's your next place value column, and I'm writing fraction format intentionally, and the third one would be thousandths. So if you have a number, for example 0.1, the 0 is in the ones column, the 1 is in the tenth column, 0.1. That's how it looks like in the decimal system. The same logic applies to the binary system, where you have the place values, the ones, the twos, the fours, and the eights for the whole numbers. And how these are made, just the same way. You take the first place value column, you multiply it by the base number, you get the next one. You take the next one, you multiply it with the base number, you get the next place value column. And if you want to make smaller place value columns going that way, you're going to have to divide by that number. So you have your halves, quarters, and eighths. And then you have your 16ths, 32nds, and 64th. If these numbers look like the numbers on a tape measure, it is by no coincidence. So a number in binary would also look like, much like in decimal, how about 0.1? Because 1 is a permissible digit, so is the 0, but those are the only permissible digits in binary. So in this situation, what I wrote is half, because the 1 is in the half place value column. So in decimal equivalent, this one equals 0.5. There, that one equals 0.5. In decimal system here, if you want to write up an amount that is less than 0.1, you have to remember that 1/10 is the same as 10 hundredths. And if you want just a little bit less than 10 hundredths, then you have 9 hundredths. So that's how it's written. So 9 hundredths is just 1/100th less than 10 hundredths. And so 1/10 is and 9 hundredths are relating this way, that 9 hundredths is just a little bit less than 1/10. Okay, to do that with decimal is fairly easy, because you have 10 digits to choose from, but in binary you don't have 10 digits. So the next number you can write, if you want to write a little bit less than half, is you have a quarter, because now the 1 is in the quarter place value column. And there's really nothing in between the half and the quarter. Just like in the decimal system, there really isn't anything between the tenths and the hundredths. There are no 50ths or 60ths or 30ths. Okay, you get the idea. likewise. So binary is gonna be a little limited. There's nothing between half and quarter. If you remember your fractions from the tape measure, you know that there is lots of fractions between a quarter inch and a half inch, but there's in a binary decimal system, okay, there's decimal system and there's binary decimal system. So in the binary decimal system, you cannot write anything between half and quarter as is. If you want to write a number in the decimal system that's between 9/100th and 1/10th, you're gonna have to have a little more than 9/100th, and you're gonna need to make some value here in the 100th column. Say, how about 95? And in this way, 95 is, you read it as 95,000th. So 95,000th is 5,000th less than 100,000th. 100,000th is the same as 1/10th. To do this one or something similar with the binary, you don't have any other digits other than zeros and ones. So if you write that number and add it to that number, and I'm just considering these two, what you end up with is that number. That digit 1 is in the, and that was adding. That digit 1 is in the quarters column, and that digit 1 is in the eighths column. You know that a quarter and an eighth is 3/8. So in fractional format, you just wrote 3/8 in a binary decimal system. And to do justice, this is how the base is typically indicated by a bracket and a small digit 2 there in it, so you know which number, which is the base for the digits of the numbers. If you want to increase this 95,000th that's in the decimal system by a little bit, you can write 99,000th, and that's just 1,000th less than 1/10th. In the binary system, if you want to have a number that is between a half and a quarter, you can add one more digit in the eighth column like this, or one more in the 16th column. That's the next one here. So now you have, if I write one there and one there, I'll just forget that part now. Now we have one digit in the eighth column and one digit in the, sorry, that's ugly, I'll just forget it. I'm gonna go 0 in the ones column, 0 there, 1 in the quarters, 1 for the eighths, and 1 for the 16ths, there, that way. So 1 for the quarters, 1 for the eighths, and 1 for the 16th. Now I wrote a quarter plus an eighth plus a 16th is, let me see, that's 4/16, that's 2/16 is 6/16, 7/16. So 0.0111 is 7/16 in a binary decimal. And to really convert this number, for example, or just any number, 0.5, to convert this 0.5 into binary is easy, because you do have a half, but if you want to try to convert a number like 0.3, good luck with it. It's not really possible. It's really hard, because you would need to make this one into a fraction, and that fraction would need to be generated out of quarters and eighths and 16ths and 32nds and 64ths and 128ths and the rest. So it's really awkward. But the system in and of itself works very fine, much the same as working with whole numbers. You can add digits and you can generate numbers that way. Any math that you do with decimals, and binary decimals, it has to be done on a piece of paper or mentally, because your calculators usually don't do this. So if I enter 0.5 and try to convert it, second function, to binary, which is I should be seeing 0.1 in binary, and it gives me 0 because the calculator only does the whole numbers, the ones that use the 4th and the 8th place value digit. It doesn't do binary decimal digits, so it gives me 0 there. And if I try to enter a decimal number in binary, how about 0.111? 0.111. It doesn't do the 0 point. It doesn't recognize the decimal dot. Okay, so you cannot do it on a calculator. You have to do math either mentally with fractions or just in writing on a piece of paper.